The rail system has never been busier. More people and more freight are on the move by rail today than ever before, which is great news for the operators, but which comes at a price.
The demand for passenger and freight services is increasing significantly, driving the need for more trains on the existing infrastructure, alongside passenger demands for a high quality service and the ever-present pressure to reduce prices or to minimise the increase in fares. Our customers want a high quality project delivered in shorter timescales, and they're very keen to see that done at lower costs. And our role as First Engineering is to make sure that we're looking for opportunities to continuously improve our approach, to make things better for our customers, and to find innovative ways of solving the problems and doing things faster on the infrastructure.
As passenger numbers and freight volumes keep rising, more traffic brings more wear and tear, which means that more trains are running on a worn infrastructure. The system needs constant repair and renewal, but engineering access times have been reduced, and the costs associated with maintaining the railway have soared. This is now the single biggest challenge facing the industry.
More trains on the network is generally a good thing, but what that means is there's a lot less availability for us to actually get onto the network and either maintain or to install new equipment. So we've got to find ways of maximising our productivity, maximising our output, and doing that in the shortest timescale so that we can keep the passenger disruption risk to an absolute minimum.
Disruptive access and blockades are complex, risky, and very expensive. They also drive away long-term customers and generate unwelcome bad publicity for the industry.
From the point of view of the passenger or the freight company, those are bad things because they disrupt service. So it's all about getting a good balance between the disruptive blockades and still providing a good quality of service for the passenger or the freight company.
For years now, the industry has been crying out for the solution to this situation. At long last, a Scottish engineering company has invented it. The non-intrusive crossover system is the new answer to this long-term problem, the way to cut costs, improve the efficiency of engineering work, and keep the trains on track. This is the prototype, developed in partnership with First Engineering. The initial design has already undergone a thorough feasibility review and full vampire derailment analysis, with complete success. The obvious benefits of the new system are there for all to see. This is the way forward.
The use of the non-intrusive crossover will cut both track maintenance costs and delays to passenger and to freight traffic. The distances between the non-intrusive crossover significantly reduce the delays of trains using the short single line working. Engineering operations will be more productive and cost efficient. And of course, the non-intrusive crossover could be used to provide an opportunity to create temporary sidings where they're needed and where we want to locate them. Well, an important aspect is that we choose the right location, and selection of the proper site, the most beneficial site, is important, and all of this work will be done preceding the installation by an experienced and well-trained crew. The installation is fairly straightforward. The components are robust, and many of the components indeed are familiar within the railway industry. We can of course engage the assistance of rail-mounted plant, which will assist greatly the efficiency of the installation.
The non-intrusive crossover system is a fantastic innovation that allows better track access and more efficient working, and you've also got the option to run trains on a parallel line while you're carrying out the work, so it's really quite an exciting development.
Non-intrusive crossover in fact has been designed such that it will have no impact whatsoever on the integrity of the existing infrastructure, nor will it have an impact on the signalling system.
This is set to change the way the industry deals with its infrastructure. But how does it actually work? Like most good ideas, it's based on a very simple principle. The non-intrusive crossover system lifts a train up by 50 millimeters, supports its weight while turning it out from the parent track, crosses it onto the other track, guides it back to the correct alignment, then lowers it onto the track itself. The system is available with left-hand or right-hand turnouts that can be used in either facing or trailing situations, but both types use the same components. Ramps to lift up the train, switch plates to turn it out from the existing railway, gut rails, standard rail between the switch plates and crossing plates, which continue to turn the train away from the existing line, crossing plates, which allow the train to cross the existing line onto the other line, a second set of gut rails which turn the train towards the other line, more switch plates to realign the train. Then, finally, another pair of ramps to lower the train back down onto the other track. Beautifully simple and completely effective, with proper railway engineering tolerances built in to keep everything smooth and easy to install. The non-intrusive crossover system has also been designed to work in all the different situations that the rail system now operates. The non-intrusive crossover system can be used in various ways. Here we see a simple crossover within a worksite in a T3 possession. It can be used by engineering trains and on-track plant as required. And here, both a facing and trailing crossover within a worksite, allowing better access and egress to major works within the possession. A temporary siding can provide instant access by on-tracking plant or storing an engineer's train. Temporary sidings could of course be used for forestry work, and even on a single line, here with a run-round facility. Short single line working around a major blockage could help trains achieve better access. And here, tracking can be assisted by the use of the non-intrusive crossover system. The non-intrusive crossover can be installed onto the parent track within a 12-hour possession of the line, and either locked out of use or utilised immediately. The unit can be brought into use within 1 hour in any subsequent possessions, and can be changed from normal to reverse in 10 minutes. By simply turning out the switch and crossing plates, the parent track is available for use during or between possessions. On completion, the non-intrusive crossover can be removed within the first available 8-hour possession of the line. This new non-intrusive system is set to pioneer a whole new way of working on the tracks. It will provide extra operating time on all routine engineering projects, reduce the complexity, risk and unwanted delays caused by blockades, and most importantly, save the government and the industry a substantial amount of money.
We've already used the non-intrusive crossover system on one of our major projects for Network Rail at Trent Valley in November and December in 2007. And we used the system to allow engineering trains and on-track plant to cross from one line to the next. This was a great success for us and really allowed us to be very efficient in the work that we did, and we think the potential for the rest of the UK network is fantastic.
The non-intrusive crossover will revolutionise the way that works are carried out on the railway network.
I believe the non-intrusive crossover system is a really superb product, and I think it will really help us to change the way we work in the UK railway industry quite dramatically. I'm really excited to be working on the project with ScotTrack, and I'm looking forward to a great future for the system.
The non-intrusive crossover will give engineers the time they need to carry out their operations to maintain the railway infrastructure and keep trains running.